Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how you find the density of a substance like lead in a pycnometer when you're not given directly the volume of the lead. And so in this problem here, we're given a pycnometer that weighs 25.60 grams. So they're giving us the mass of the pycnometer when it's empty. And when it's full with water at 20 degrees, it has a mass of 35.55 grams. And then they give us the density of the pycnometer, or I'm sorry, of the water at 20 degrees, and that's 0.9982 grams per milliliter. And then they say when 10.20 grams of lead is placed in the pycnometer, and the pycnometer is then again filled with water. And what this means is that you're adding a certain amount of grams or mass of lead to the pycnometer, but you're not filling the pycnometer completely with the lead. So this is going to take up a certain amount of volume in the pycnometer. And so the rest of that volume is then being filled with water at 20 degrees. And so we know the density of that. And then they're saying with the water and the lead in the pycnometer together with the mass of the pycnometer is going to be 44.83 grams. And then they want to know what is the density of lead in grams per centimeters cubed. So again, with a problem like this, any word problem, you're going to pull out the information and then use that information to find the answer you're looking for. And so here we're looking for density, right? So they want to know density. What is the density of the lead in the pycnometer? So, so we need to know what density is. So density is equal to the mass over the volume of the substance. So if we could find the mass and then find the volume, all we need to do is divide the two, and we've got our answer. And so they're looking for, they want to know what the density of the lead is. Okay, the density of the lead. So we need to know the mass of the lead. Did they give us the mass of lead? Yeah, so they say when 10.20 grams of lead is placed in the pycnometer. Now, let me pause for a moment and explain what a pycnometer is. A pycnometer is a device, it's usually a glass tube of some sort, that you put substances into in order to find, like, say, specific gravity or the density of the substance. You can put liquids or solids in there. And that's what it's used for. I don't have one on me, otherwise I would show it to you. But it's like a glass tube. It looks kind of like a raindrop, sort of shaped, and that's what a pycnometer is. And so it's appropriate that we're looking for the mass or the density of lead using this pycnometer. So we know the mass of the lead. So we have this. So we have the mass. So now all we need to do is find the volume of that lead in the pycnometer. So they give us a lot of information that we're going to have to use to find this out. So let's see. So here they say the pycnometer weighs this. This is when it's empty, 25.60 grams. And it weighs 35.55 grams when it's filled with water. So we could subtract that out and we could get the mass of the water that's in the pycnometer. So this is where the pycnometer is empty, it has nothing in it, and then you fill it with just water. And so the volume of the water that is occupied in the pycnometer should be the volume that the pycnometer can hold, right? So we can find the volume of the water, which is going to be the same as the volume of the pycnometer as well. So we can take 35, we can get the mass of all that water in the pycnometer. So we take 35.55 grams. That's with the water and the pycnometer together. Okay. And we subtract out the mass of the pycnometer. 25.60 grams. And there we get, where's my calculator? All right, so we're going to take 35.55, subtract 25.60 equals, and you get 9.95 grams. So we get 9.95 grams, and that's of the water, H2O. Now, again, each step of the way, we need to keep track of the sig figs because we're going to have to figure out how many sig figs are going to be in the density that we want to calculate. So we're going to need to keep track of sig figs along the way. So the rule for subtracting and adding is that the answer should have the same number of decimal places as the least number of decimal places in the numbers that you are adding and subtracting. So here we have 2. The least decimal place is at the hundredths place, and here the least decimal place is the hundredths place. So the least is at the hundredths place. So I'm going to underline that last digit in the hundredths place, so that way I don't forget about sig figs. Okay, so now I have the mass of that water. Now I can use that mass and use the density of water at 20 degrees to figure out the volume, okay, of the water. And that, again, the volume of the water is going to be the volume of the pycnometer when it's empty, okay? Or another way of saying it is the total volume that it can hold, that the pycnometer can hold. Okay, so since I have density, remember when you have density, you have something per something. You have grams per milliliter. That is a conversion factor. So I can use density as a conversion factor. So since this is telling me that I have 0.9982 grams for every milliliter, I can write that as 0.9982 grams of water is equal to 1 milliliter of water at that temperature. Now you might be thinking, well, isn't 1 gram of water equal to 1 milliliter? Isn't that what it is? Well, that depends on the temperature, and that's usually at room temperature or 25 degrees temperature. But here we have 20 degrees temperature, so the density is not going to be exactly 1. So now that we can use this, I can take my answer here, put it over 1, and then I can use the density ratio as a ratio to convert to milliliters. So I have grams on the top, grams of water. So I'm going to put 0.9982 grams of water. So 0.9982 grams of water. And then I have 1 milliliter of water there. The grams of water cancel out. And now I'm going to get milliliters of water. So if I do this calculation, so I got 9.95 divided by 0.9982 equals, and I get 9.967. So 9.9. So I get 9.967. Let me put another digit in there. 9 milliliters of water. Now, again, I need to keep track of sig figs. So here, since we're multiplying and dividing, the rule is that your answer should have the same number of sig figs as the least number of sig figs that you've been multiplying or dividing. So here we have 3 sig figs, and here I have 4 sig figs. The 0 in the beginning is never significant. So those leading zeros at the beginning of your number, zeros to the far left of your number are never significant. And so you only have 4 here. So the least number is 3, so I can keep 3 here. So I have 1 here, 2 here, so 996. I can keep the 996, and then I drop the 7 and the 9. So I'm not going to drop those because I don't want to have a rounding error. So I'm going to underline it so to remind myself that that's my last digit. But I'm going to keep these just because I need to continue to use that in other calculations. And if I round too early, then I'll get a rounding error. So I'll keep those. Okay, so now that I have the volume of the water that was occupied in the pycnometer, this is the volume of the pycnometer. This is the total volume that the pycnometer can hold. So now we can go and figure out, well, we need to know the volume of the lead. So here, we're told that 10.20 grams of lead is placed in the pycnometer. And then the rest of that volume that's left over, that this volume here, the rest of this volume here that's left over is filled with water. We don't know how much water. But we are given the total mass of the pycnometer, the water, and the lead. So we know the mass of the empty pycnometer. We also know the mass of the lead. So that way, if we subtract that from the total mass, we can get the mass of the water that's left over. So let's do that. So then, and the reason we want to do that is because once we get the mass of the water, we can get the volume of the water from the density, and we can then know how much volume that occupied the pycnometer, and then subtract that from the total volume that we have here, and that'll give us the volume of the lead that's occupying the pycnometer. So we have, where is it? 44.83. So we have 44.83 grams total. We're going to subtract out the mass of the lead, 10.20 grams. And we're going to subtract out the mass of the empty pycnometer, so 25.6, so 25.60 grams. Okay, so let's calculate that. So we have 44.83 minus 10.20 minus 25.60 equals, and I get 9.03. So I get 9.03 grams of water. So the 9.03 grams is the water that's occupying the pycnometer. So now that I have the grams of the water that's occupying the pycnometer with the lead, I can now use the density of the water again to convert that to volume. So now let's do that. So I have 9.03 grams of water over 1. And I'm going to multiply that by the conversion factor of the density. Again, I have grams of water, so I want grams of water on the bottom. So I'm going to put 0.9982 grams of water on the bottom. So 0.9982 grams of water on the bottom. And then 1 milliliter of water on top. So 1 milliliter of water on top. So grams of water cancels out. Now I have milliliters of water, the volume. So now I can calculate the volume of the water that is in the pycnometer. So 9.03 divided by 0.9982 equals, and I get 9.04. I want to just double check. Yeah. So 9.04. Let's see. 9.04. I got a few more digits. Let's put 6.2. 6.2. Okay, so that's milliliters of water. And again, I want to keep track of sig figs here. So here again with the subtraction, I need to know how many digits I can keep. So again, the rule for adding and subtracting is that my answer has the number of sig figs, or I should say the number of decimal places in my answer should be the same number of decimal places of the least number here in my answer. So the last digit here is in the hundredths place. The last digits here is in the hundredths place, and the last digit is in the hundredths place. So that means the least precise position or the least number of decimal places is 2, or the hundredths place. So I'm going to underline this to let me know. And same thing here. Again, the number of sig figs, the rule is if you're multiplying and dividing, the answer should have the same number of sig figs as the least number of sig figs in the numbers that you're multiplying and dividing. So here I have 3 sig figs. The 0 is significant because it's sandwiched between two non-zero numbers. So that is a 3 sig figs there. And again, I have 4 here. This 0 again is not significant because it's a leading 0 and they're never significant. So the least number is 3, so I count 1, 2, 3. So the 4 is my last significant digit. I'll keep the 6 and a 2 because I'm going to be using this in a later calculation, so I don't want a rounding error. Okay, so I have water in milliliters. So this is the volume of the water that's occupying the pycnometer, but I don't want the volume of the water. I want the volume of the lead, so that way I can find the density. So how do I find the volume of the lead? Well, I know the total volume of that the pycnometer can hold. I know the volume of the water that's occupying the pycnometer. So if I subtract these two, then the leftover volume has to be the volume that's occupied by the lead. So if I subtract that, so if I take 9.9679 milliliters, subtract 9.0462 milliliters of the water. And what do I get? So 9.9679 minus 9.0462 equals, and I get 10.889, so on. No, I did that wrong. I added when I should have subtracted. So 9.9679 minus 9.0462 equals, okay, that looks better. So 0.9219. 0.9219. So that's going to equal 0.921. Did I say 9? I think 7. 97 milliliters of water. And here, milliliter, they want centimeters cubed, but centimeters cubed and milliliters has a 1-to-1 relationship. So it's 1 centimeter cubed is equal to 1 milliliter. So 0.9217 milliliters is going to be the same as 0.9217 centimeters cubed. So we now have, this is the volume of the lead that is occupying the pycnometer. They gave us the mass of the lead earlier, so now we can find the density So density is equal to mass over volume. But first we need to identify the number of sig figs here. So again, we're adding or subtracting here. The rule is that the answer should have the least number of decimal places. So this answer should have the same number of decimal places as the least number of decimal places here. So we have to go back to our numbers here. So 90, where is it? So 90462. So that's the last digit there. And then the 9.966 is the last digit there. We just kept these to avoid rounding errors. So we have 9.96. So we have the last place is in the hundredths place. The last place is in the hundredths place. So 2 decimal places. So that means that we're only allowed up to the hundredths place. We're going to keep these for our calculation because we need to use it to calculate the density and we don't round a rounding error. So now we have our last step. So we're going to take the mass, 10.20 grams, divided by the volume that we got, 0.9217 centimeters cubed. And so again, we're allowed only the 2 up to there as a sig fig, and for this we're allowed up to here for sig figs. So now we just need to calculate. We'll divide. So we're going to take 10.20 grams divided by 0.9217 centimeters cubed equals, and we get, that's going to be equal to 11.066 grams per centimeters cubed. And now we just need to figure out how many sig figs were allowed in our answer. Remember, since you're multiplying or dividing, the rule is the answer should have the least number of sig figs that are in the numbers that you're multiplying and dividing. So here we only allowed up to the 2, so we have 2 sig figs here. Here we have 4 because we're allowed up to the 0. The 0 here is significant because it's at the end of a number and there's a decimal point. The 0 here is between 2 non-zero numbers, so that's significant. So we have 4 significant figures here. And so the 2 is the least number, so we're only allowed 2. So 1, 2, and the rest gets cut off. So this is a 0. So this, we don't need to round the 1. So we're going to keep 11. So 11 grams per centimeter cubed is the answer. I hope this was helpful. If you enjoyed this video, please hit the like button, share the video, put a comment in the comment section. Let me know what you think. If you have any other questions, please subscribe to the channel. And thank you very much. Have a great day.